Hey folks, and welcome back to Algebra 2. Today we're going to be covering something that doesn't have to do with complex numbers. Remember, this unit is also about quadratics. So today we are really talking about quadratics more than complex. We'll get to complex at the end. So we're dealing with a blast from the past in systems of equations. You've seen it in Algebra 1, you've seen it in 8th grade, and it might be quite some time ago, but we're going to get through it. So let's take a look at how quadratics and linears intersect. So before we start with solving quadratic linear systems, we should take a look at what they might look like on a graph and what that can give us. So here, the quadratic in all three of these is pink and the linear is blue. And we can tell here they intersect twice, so we can have two solutions. That is a distinct possibility. Here, this graph is tangent to the parabola, so we can have one solution. That perfectly works. It happens sometimes. And here, we can have no solutions. Because your parabola doesn't intersect your linear equation at all. And this is typically what they look like. We're looking for the common solution that makes both of these equations true. And just like you remember when you were dealing with something that might have looked like this, where you were doing it in Algebra 1, we're like, oh, this point x comma y is my answer. You're looking for a point or points, plural, that make both of these true. Now, the important thing to recognize here is once you get past the shock that there might be two answers, these are really similar to how you did these. We're not going to do elimination, we're just going to do substitution. They're both equal to y. Because of that, they're both equal to each other. So I can say, well, 3x is equal to x squared minus 2x. Well, here on out, this is just a normal quadratic that we've solved a bunch. You've seen the quadratic formula, you've seen factoring, you've seen a bunch to do it. I'm going to subtract 3x from both sides. I'm going to have minus 5x. It's up to you how you want to solve this out. You can do the quadratic formula. I'm going to do it by just factoring. So that means 0 is equal to these two. I did my GCF here. Well, that means that x equals 0, x minus 5 equals 0, x equals 5. Careful. We can't stop here. We have our two answers, but we're looking for 2 points. So each one of these x's needs a y. Well, that's not the end of the world. We know how to get that. You just take these answers and you plug them in. So we're going to call this one purple answer. And let's just do it. I'm going to choose this second equation to plug into. You might be wondering why I'm choosing the second one. Quite frankly, it's easier. It's just one thing to replace. So that means it's 0. My answer is 0, 0. That's one of them. Now I need to do the same thing to the other using 5. Well, I can do 3 to 5. Well, that means it equals 15. So that means my point is 5, 15. So let's take a look at how we would go about and check this using Desmos. So we can see here that I've already plugged in both of my equations. We have the red parabola, we have the blue linear equation. And we can tell if we zoom out that they do intersect twice. So we were right in finding two answers. And I can plug one point here. That gives 5, 15, which was one of our answers. And a second one here, which 0, 0. That was the second one of our answers. You can also check by going to the table and seeing which points are on both of them. 0, 0 is here, 0, 0 is here. And if I plug 5 into this, I should get 15. If I plug 5 into this, I should also get 15. Just telling me, we're right. Our graph supports the idea. So here we have another one. It looks different because the second equation, the linear, isn't in y equals mx plus b form, otherwise known as slope-intercept form. This is in standard form. It's x, y equal to a constant. Well, we're going to do the exact same thing as we did before, but our first step is going to be to convert this into y equals 4. So I'm going to do that by rewriting, and then I'm just going to subtract 3x on both sides. So I'm going to have negative 3x plus 18. Well, now I have this equation set equal to y, this equation set equal to y. Because of that, I can set them equal to each other and solve. Let's take a look. 2x squared plus x minus 108 is equal to negative 3x plus 18. Don't let any of this get in your way. Well, we're going to have 2x, add the 3x over, so plus 4x. Subtract the 18 over. That's going to be negative 126 equals 0. You have a couple options here. You can definitely use the quadratic formula. I think a lot of people will use the quadratic formula, so I'm going to factor to show an alternate method. So that's going to be factor 2 out, so plus x minus 63 equals 0. And I can again factor that and just say this is going to be, oh, excuse me, that should be a 2. That's going to be x plus 9, x minus 7 is equal to 0. I just factored using factors and sums. So set everything that can be equal to 0 equal to 0. 2 obviously doesn't count. And solve out. Negative 9, positive 7. Again, you might be tempted to say, woo, we're done! Don't do that, because if you do that, you are unfortunately incorrect. What we're going to have to do is plug x in as negative 9 and x in as positive 7. So again, you can choose either one. I'm quite frankly always just going to choose the linear, because then I don't have to solve out anything with a squared. If you want to choose something with a squared, cool. I'm also going to choose this one simply because it's already set equal to y. So I'm going to get y is equal to negative 3 plus 18. Y is equal to negative 3 plus 18. And I'm just going to plug in what we have. Negative 9. So that means that's going to be negative 27 plus 18. So that means it's just going to be negative 9. So my second one, I'm going to plug in 7. Oh, excuse me, folks. That's a positive. So positive 27 and 18, that's going to be positive 45. I'm sure if we were in class, a lot of you guys would have said, hey, wait a second, Mr. Gallagher. So that's going to be negative 21 plus 18. So that's just going to be equal to negative 3. So that means our solutions are 7 comma negative 3 for the pink. And we're also going to have negative 9 comma positive 45 for the purple. And you can, of course, check these on Desmos by graphing them out. I would really encourage you to do that before you hit enter on Delta Math. Awesome. So you've seen 2 examples with it. I purposely kept this short because you also have that writing assignment. What you should do now, before you start the Delta Math, is take a look at the writing assignment. It's a separate assignment on Google Classroom, so that way there's no confusion if you do the Delta Math but not the writing assignment. And ask any question you have now in class. If you want to start the writing assignment, which is probably going to be a larger percentage of your grade than the normal classwork, that might be a really good idea. So use this time wisely, ask the questions that you need. You don't have a reading check for next class. You do have an exam next class, so please, please, please study. I'm also going to have all sorts of reminders popping up on Google Classroom. They're already scheduled, so you do not forget. Have a great day, folks. Remember, ask questions if you got them, and I will talk at you soon.